Hi. Clearly explain what is diffraction. Diffraction is nothing but bending of light. This bending of light can be explained in terms of crystal. This phenomena is used in crystal. Why this phenomena used in crystal? This phenomena is used to determine the structure of the given crystal. The structure of the given crystal. For this determination, then the science can be called as crystallography. So for this purpose, we are introducing some X-rays. These X-rays are used in the phenomena of diffraction. Why you are using X-rays? This X-rays wavelength lambda value is equal to 1 angstrom, because this lambda value is nearly equal to interplanar distance of the crystal planes, interplanar distance of the lattice planes. What is interplanar distance? The interplanar distance is nothing but you have different lattice planes. The distance between successive lattice planes can be taken as d. This d is matched with lambda. They have easily and accurately determined the structure of the crystal. Then the phenomena obeys the science is called as crystallography. Crystallography is the branch of physics which can explain or you can deduce the structure of the given crystal. For this purpose, you can introduce the ray is called as X-rays. These X-rays are discovered by who? The scientist. The scientist is W. Röntgen. In 1859, they are introducing for unwanted rays came from his experiment. Those unwanted rays can be called as X-rays. I am already completely gave the story about the X-rays. This is very useful for future classes. You must tell to the students in your students. So that is the very important story about the X-rays. So this is. So according to this crystal structure, this crystal diffraction, the first topic is X-ray diffraction. The first topic is X-ray diffraction. X-ray diffraction. X-ray diffraction. In X-ray diffraction, the first we can deduce the relation that is called as Brax relation. This is also called as Brax law. Brax is the scientist. He is used the diffraction pattern. He used the diffraction pattern by using X-rays. So, what is the relation among the Brax relation? Brax gave the relation between wavelength of X-rays wavelength, which is indicated by lambda, of X-rays, comma, wavelength of X-rays, and distance between the planes, nothing but interplanar distance, which is indicated by D, and angle of incidence, I'm taking theta. So these three relations, these three topics, particularly wavelength, interplanar distance, and incident angle, among these three they can give the relation. That relation is also already known, that is called as 2D sin theta is equal to n lambda. This is the Brax relation. Here n is nothing but order of diffraction. So particularly here using the lambda. Lambda is nothing but wavelength of X-rays. These are already known. This value is approximately equal to 1 angstrom. So D is already calculated. How to D is calculated? The interplanar distance for the any crystal can be taken as D is equal to 1 by square root of h square by a square plus k square by b square plus l square by c square. By using this relation, nothing but you can know the plane, lattice, Miller indices. For Miller indices you are know, easily you can calculate the D value. So lambda is known, D value is known, D known, lambda. You can take the first order, second order, third order, maxima and minima conditions are occurred. So based on this, how the angle of incidence is now calculated. So theta can be calculated. For this relation, you can deduce nothing but proof of the Brax relation. What is the proof? Which is very important question also. So for this Brax relation, you can consider one crystal. What is crystal? Crystal is nothing but periodical arrangement of atoms in three-dimensional point of view. Nothing but spacelet. So what is spacelet is? It is the combination of lattice points in three-dimensional point of view. So I am showing the crystal structure. In crystal structure, what are there? It is a combination of lattice points and bases. What is bases? This is the minimum number of atoms or molecules which are repeated. They can give the complete crystal structure. These are the. So you can consider horizontal lattice planes. So I am considering planes. So lattice plane is nothing but the plane passing through the lattice points. This is the first plane. This is the second plane. Third plane. Fourth plane. According to the lattice plane, crystal also defined as it is a combination of different lattice planes. So I am taking the first plane, second plane, third plane, fourth plane, fifth plane. Everyone knows what is the known point. The distance between successive lattice points is nothing but interplanar distance. I am considering the lattice planes. Which set of lattice planes? I am taking the parallel lattice planes. Nothing but these all lattice planes have the same set of Miller indices. H, K, L values are always be equal. So this is interplanar distance can be taken as D. This is also D. This is D. This is D. And one more is known. The successive lattice points. Distance can be taken as lattice parameter is A. At any point of view, their surroundings, lattice distance, lattice point distance can be taken as lattice constant. So, in this way, I am introducing X-rays like as one X-ray is instanding on the particularly lattice point, this one. Another also two light rays, particularly X-rays are instanding on the lattice planes. X-rays are instanding on the lattice planes. Second is instanding. Suppose you can instand in the lattice. X-rays are AB is the incident ray. Again A dash, B dash is also the. So this is the incident X-rays, and the wavelength is exactly 1 angstrom. So the X-rays are instanding on the lattice points B and B dash. These X-rays are reflected and transmitted. So this is reflected ray. This is also reflected ray. This can be transformed. This can be transmitted like this. Nothing but you can assume you are assumed two X-rays. One is AB, another one is AB dash. AB dash is instanding on the first lattice plane, AB is instanding on the second lattice plane. So according to this, the angle is instanding can be taken as theta. The angle can be instanding on theta. According to AB and AB dash, which light ray is additionally travelled? The second light ray A dash, B dash is additionally travelled, that is B to some point. This is, you can take as C. So BC is the additional distance. Up to the C, A dash to C and AB, they can travel same distance. C to B dash is the additional distance. C to C dash is the additional distance. I am drawing one perpendicular. So this distance is particularly distance D. That distance can be taken as D. The distance can be taken as D. So this is reflected ray. This is also reflected ray. Up to this, which light ray you can draw the like this. Suppose this can be taken as A, B, C. This one is D, E. You can draw one F. You can draw F. So AB and A dash B, they can travel the additional travel. BF is the additional travel. Otherwise, FD is the additional travel and D is the additional travel. Nothing but the extra distance. Extra distance traveled by the X-rays is, one is FD is the extra distance plus one more is DE is the extra distance. This extra distance, according to ray optics, the extra distance can be called as path difference. That is called as path difference, which is indicated by letter delta x. So according to the theory, delta x value is equal to FD plus DE. FD plus DE. It is maybe the angle is theta. Here also angle is also theta. Here how many two angles are there? One is theta, another one is P. So what you want to calculate, FD value can be calculated and DE value is also calculated. They can get the path difference. What is the path difference? The extra distance travelled by the light rays. Same light rays are instanding on the plane. They have some difference in the length travelled in the path. That extra path can be travelled That difference can be taken as path difference. According to data, we want to calculate FD and DE value. So, you can consider the triangle from the diagram. The triangle is D, B dash, D, B dash, D, B dash, E. So it is a one right angle triangle like this. This is, you can draw the normal, nothing but here is E. You can take the angle theta. Theta is existed at B dash. Theta is existed at B dash. And one more is D. According to this, what you want to calculate? You can calculate the DE value. You can calculate the DE value can be calculated. And B dash D is also known, that can be taken as D. So from this equation, you can consider the sine angle. So according to trigonometric rules, sine theta can be taken as DE by DB dash. We want to calculate DE value. D is equal to DB dash into sine theta. DB dash value is D sine theta. This is the DE value. This value is D. D is equal to D sine theta. In a similar manner, you can consider one more triangle, that is FDB dash. This is also one more right angle triangle, that is here can be taken as F. Angle is existed at B dash, that the D. B dash D is D. Here also you can take as sine theta is equal to dF by dB dash. Therefore, dF is equal to dB dash sine theta. So, dF value is equal to dB dash value is d sine theta. So, according to our path difference is nothing but delta x is equal to FD plus DE. So, you can want to calculate path difference. Delta x value is equal to d is nothing but d sine theta plus d sine theta. D sine theta plus d sine theta is nothing but 2d sine theta. This is path difference of X-rays are incident on the lattice planes. X-rays are incident on the lattice planes. So the path difference is 2d sine theta. 2d sine theta. The path difference is 2d sine theta. So these two light rays are incident on the lattice planes. These are the reflected rays. Depending on reflected and incident rays, the rays are additionally traveled distance can be taken as path difference, that is FD plus DE. This is calculated according to trigonometric relations. That path difference can be you get the result is delta x value is equal to 2d sine theta. So this is path difference value may be this path difference value may get either maximum value, otherwise minimum value. Maximum value or minimum value. Depending on maximum and minimum, 2d sine theta value may get maximum value, otherwise minimum value. Maximum you get nothing but intensity is also maximum. At what condition maximum is existed? At what condition they get the maximum is incident is getting? So here the some reflected rays are existed like this. So F is there, B2 G and E2 H. The reflected rays can be taken as BG and DH. The reflected rays can be taken. Reflected rays according to the diagram is can be taken B dash G and DE, DH. DH. These two rays are existed in phase. Otherwise, those are existed in out of phase. Reflected rays are existed in phase or out of phase. In phase is nothing but there is no angle difference. Suppose incident ray and reflected rays. You can incident ray is some 90 degrees or otherwise some 60 degrees. The reflected ray gets also 60. Nothing but incident ray and reflected ray get the in phase. In a similar fashion, the two light rays are in phase. There is no phase difference. Nothing but here the phase difference, delta x value, pi value is equal to 0. Here out of phase is nothing but delta pi is not equal to 0. That is the condition in phase and out of phase. Suppose the reflected rays are existed in phase, they get the result is maximum. So for maximum condition, delta x value is always equal to n lambda. This is with respect to for maximum. Minimum value, delta x value is equal to 2 n minus 1 lambda by 2 is the minimum value. So according to our relation, you can consider the maximum intensity. According to our relation, you can get the maximum intensity. Maximum is nothing but delta x value is equal to n lambda. Here delta x value is equal to, according to derivation, you get the result is 2d sin theta. According to the theory, delta x value is equal to n lambda. From these two equations, we can equate 2d sin theta must be equal to n lambda. 2d sin theta must be equal to n lambda. This is the Brax condition. This is called as Brax condition, which is also called as Brax law. Here n is order of the spectrum. Order of the spectrum. It may be n value can be taken as either 1, 2, 3 and so on infinity. If n is equal to 1, that n value can be taken as 1 is nothing but first order. So according to the theory, some problems are given. The spectrum is existing first order. So first order is given nothing but you can place n is equal to 1. Then Brax condition is converted into 2d sin theta is equal to lambda. For n is equal to 2, nothing but second order spectrum. Second order spectrum is nothing but n is equal to nothing but 2d sin theta is equal to 2 lambda. 2 get cancelled, nothing but d sin theta is equal to lambda. This is used to for second order spectrum. So X-rays are incident, the light rays are reflected, nothing but they can get the reflection, nothing but diffraction is existed. After the diffraction, they get the relation along the lattice planes, particularly distance between the lattice planes and incident light ray wavelength is called as 2d sin theta is equal to n lambda. 2d sin theta is equal to n lambda. That is called as your Brax relation, which is also given in the short answer questions in our exam pattern point of view. Very, very important relation. Based on this important relation, you can go through the next topics. So for our coming topics, you are taking or you are introducing this relation. Bragg's condition, nothing but diffraction condition. You must take 2d sin theta is equal to n lambda. Here d is nothing but distance between the lattice planes. Theta is nothing but angle of incidence. Lambda is nothing but X-rays wavelength. Otherwise, you can does not use the X-rays due to some unwanted or some other rays are used. Like as you can incidenting on the electrons in the form of rays. You can take the lambda can be taken as wavelength of electron beam. Suppose you can use the proton beam. So lambda can be taken as wavelength of proton beam. So what the light rays are incidentting on the crystal, you must take lambda, nothing but wavelength of those beams. So according to the diffraction pattern, maximum for crystallographic method, maximum you are introducing or you are incidenting of the rays are particularly X-rays. That is called as Brax relation. That Brax relation is nothing but 2d sin theta is equal to n lambda. 2d sin theta is equal to n lambda. This is the derivation part of Brax relation. After completion of Brax condition, why you are using Brax condition? This Brax condition is used to determine the crystal structures. Determine the crystal structures. Determine the crystal structures. So based on this Brax condition, the next topic can be taken as X-ray diffraction methods. The next topic is X-ray diffraction methods. There are mainly for crystallographic methods, there are mainly 4 types of methods are there based on X-rays. So at this condition you must use the X-rays. X-rays is nothing but the wavelength of X-rays can be taken as 1 angstrom, approximately equal to 1 angstroms. For diffraction method, so you can use the diffraction method is nothing but relation is 2d sin theta is equal to n lambda. Based on these two, you can clearly determine the crystal structures. So to determine the crystal structure, then the phenomena of the science can be called as crystallography. So crystallography methods are mainly 4 based on X-ray diffraction. First method is Lace method. First diffraction method is Lace method. Second is Bragg's spectrometer. Third method is rotating crystal method. Fourth method is powder photograph method. So according to our syllabus, out of these 4, only 2 methods or 2 experiments are given. That is called as, one is lay pattern, second one is powder pattern. So up to first 3 in this crystal or these methods are used for completely crystals. Those are mainly existed like as solid form. So you have, I am giving the one crystal. This crystal is existing in the solid form. What is the structure of this crystal can be explained based on, out of these 3 you can use either lay method or Bragg spectrometer, otherwise rotating crystal method. Up to these 3 methods are used to determine the crystals which are in the solid form. Only you can take the crystal, you can determine the structure of the crystal which is in powder form. Nothing but you can take the one solid crystal. On this crystal you can apply the force. This solid is broken into some small pieces. Again you can apply the large amount of force. That complete crystal is converted into powder. So based on this powder, like as your phase powder, you can take that. That phase powder structure can be explained by using powder photographic method. So this 4th method is used for the crystal must be existed in powder form. Other 3 are used to the crystal structures can be explained. The crystal must be taken in the solid form. So this is the method to determine the structure of the crystal. Then the science is called as crystallography. So these 4 methods are nothing but crystallographic methods. So in our syllabus only 2 methods are there. One is lay method and another is powder method. In our next class we can discuss very clearly with respect to experimental point of view. Okay. So each and everyone must practice the Brax relation, which is also very important. So based on that relation you can follow the methods also. So everyone must practice 1 or 2 times practice. That derivation is very easy. To understand the topic. So okay, in our next class we can discuss the experimentals for crystallographic methods. Okay, please follow it.